Hey friends, welcome to our academic video for this project. We first want to talk about materials, and a big part about what makes these prosthetics comfortable, lightweight, and functional is what they're made of. Now obviously, the materials that we're going to be using look a little bit different than the ones that real biomedical engineers use, but we figured we'd fill you in on a few that help them get the job done. They use materials like acrylic resin, carbon fiber, thermoplastics, aluminum, silicone, and titanium. Each of those materials have different strengths and properties, but a combination of them together can build a pretty effective design. We also mentioned that modern day prosthetics don't just look like a pirate's leg anymore. There's a lot of moving parts. And did you know that the brain and the body contain billions of neurons? And that's how they communicate with each other. They send electric and chemical signals to tell the other body parts how to move. Now this is a little bit of a challenge question, but can you quickly pause this video and brainstorm how can engineers and researchers take advantage of those electric signals being sent to help improve the lives of their patients and their prosthetics? Yep, many prosthetics have small electric motors in them that can sense the tiniest electric current and pick up signals from the brain that tell something like a finger to move. One slight problem though is it has proven hard to control just how fast or hard those extremities move or clamp down. For example, picking up an egg would get the same signal from the prosthetic as something like picking up a baseball. Do you see the problem there? Potentially cracking the egg? That is up until recently though, because a team of biomedical engineers at the University of Utah are working on a prosthetic hand that can not only take signals from the brain and move itself, but it can also sense surfaces. That can be important when it performs tasks like picking a grape off the vine successfully without smushing it, or picking up the egg without cracking it. It's going to be pretty neat to track the progress of that hand and the future leaps that awesome engineers like those are going to continue to make. Finally, and we will get into this a little bit more in the next video, but there is a cool scientific process when it comes to making these prosthetics, and if you enjoy challenges, this might be a career for you. Each day and each project is unique, and they're fun to go about solving. First, you have to go about measuring it and seeing just how big or small it has to be, right? Then comes setting some goals, because a patient who wants to run in their prosthetic will look much different than one that just needs to walk in it to get around. And the finishing touches are just how to go about attaching it and shaping it to help the patient out best. So thanks a ton friends, we're excited to show you some examples and how to apply this science here in the next video.